Welcome to Dig Deep, the mining podcast. In this podcast, we go deep into mining news, hot topics, and live interviews with mining professionals and leading figures in the mining industry. Introducing your host, Rob Tyson, founder and director of Mining International and Mining International Executive, a leading global mining recruitment and headhunting agency.
Hi mining community, welcome back to another episode of the Dig Deep, the mining podcast. And today's guest is Michael Zolotov, who is the co-founder and CTO of Razor Labs, who are a leading mining technology provider that delivers advanced predictive maintenance with its flagship project, DataMind AI. Razor Labs AI sensor fusion technology provides real-time conditioning monitoring, root cause analysis, and prescriptive actions to prevent failures before they happen. Michael's a serial entrepreneur, an expert in AI, radar, and advanced analytics. He has built and led companies through IPOs and acquisitions and has helped scale Razor Labs globally. Most importantly, he's pioneered AI sensor fusion in mining, and he's on the podcast today to discuss Razor Labs' origins, how DataMind AI uses sensor fusion to cut costs, mining downtime through real-time monitoring, examples of fast return on investment, its impact on maintenance practices, the transition to trusted AI systems, and future direction for AI in mining. Welcome to the podcast. How you doing?
Thank you, Rob. Pleasure being here. Thanks for having me.
Thank you for your time. So as we always start these podcasts off, I just wondered if you can just tell us a little bit about yourself. Obviously, I just gave a brief overview there, but if you can just tell us a little bit about yourself, maybe a little bit of your background in what you've done in your career, and how your career has developed to obviously today working for Razor Labs.
Sure. So we have, I would say, a bit of a unique background. We are three entrepreneurs, serial entrepreneurs. We started our journey together more than 10 years ago already. We've built a group of AI companies in different fields, and we identified, it was roughly 8 years ago, the mining sector. When I say mining, obviously it's natural resources, it can be processing plants, smelters, and so on, as a very high potential for AI disruption. And that's why we've built this product that you just mentioned, DataMind AI, which is essentially like an automated doctor for machines, both fixed assets and mobile fleets. And being basically able to continuously monitor this equipment and prevent catastrophic breakdowns and really prolong equipment lifespan, reduce maintenance costs, and so on.
Right. So I just wanted me to just tell us a little bit about the company, and I suppose that start from the beginning. What inspired you to actually start Razor Labs and obviously build DataMind AI? And then obviously, what problems were you looking to try and solve?
So it's a good question. When we started 10 years ago, it was right in the beginning of the modern AI revolution, where the first neural networks really came out. The first neural networks that were trained in the modern way. It was the first time that we had these models that were thinking pretty similarly to how we humans think. And we thought that it would make a tremendous impact to productize these and to really make an impact on actual enterprises. Back then, we actually started as an AI, with AI projects. We're doing amazing stuff for medicine, for retail, for heavy industry as well. Really building these models that was more prominent back then in the academy, and really taking them to real production, real organizations that were using them to gain, to gain value. And around that time, we were looking for an area where we could productize the offering and where we could focus on. And the uniqueness here is that it was a bootstrap company, and we actually reinvested the profits into the R&D of that product, of DataMind AI. We got from completely bootstrap from 0 to 100 team members in Razor Labs, and then we IPO'd the company with the message of applying the focus specifically on the mining sector, because of the high potential there. If you look at other industrial sectors, whether it's plastic or whether it's others, there is no second to mining in terms of the effect or the worth of 1 hour of downtime. And that's why we chose mining. Back then, we started this journey specifically in mining roughly 10 years ago. And we were really expanding the offering ever since. We started with fixed assets, then expanded to mobile fleets, and so on. And obviously, the IPO, we IPO'd 3 years ago for a valuation of $150 million. And the money that we raised allow us to grow faster and to more geographies. We now work in Australia, we work in Africa, in Latin America, North America, and so on.
So what's the true cost of unplanned downtime in mining, and how does DataMind AI help reduce that?
So it's a very good question, and it's not as a simple answer as it seems, because it really depends on the site. And I'll give maybe two of the main groups of sites that we stumble upon, that we work with. One type of sites, I will give an example, many underground sites that have these, conveyors that are basically conveying all the material from the mine to the processing plant. The major cost there is the cost of 1 hour that is loss of production, purely throughput. They will be selling less material for every hour of downtime that they will have. So trying to quantify the worth of an hour there is easier. Basically, you take the throughput, you see how many tons per that hour they produce, you know their profits for that ton, and you basically multiply that, and you know the cost in dollars, for 1 hour. Normally, a failure is obviously not an hour or two. Normally, a failure is multiple hours. In critical or catastrophic failures, it can be even days. And then you can really get to, in these sites, hundreds of thousands of dollars per failure. And obviously, there isn't a single failure on site. When you look at a year, it can be really dozens and dozens of failures. So that's one group of sites where we're more looking at the downtime itself and its impact on basically lost revenues or lost profits. There is another group of sites where the site itself is not a bottleneck. Even if it would have more uptime of the equipment, it would not produce more because it is dependent on the material that's coming in, and that material is obviously limited. And there, the business case lies in mostly reduction of maintenance costs, meaning spare parts, labor, and so on. And basically, the name of the game there is, number one, to prolong equipment lifespan. Because if you prolong lifespan, whether it's in engines of haul trucks, which are like $400,000 per engine, or the tires, or whether it's the motor of the crusher, if you prolong the lifespan, you're able to replace less of them. Obviously, every replacement has a cost. And then when you look at over, let's say, years time, or 3 years time, or 5 years times, you've done less replacements, meaning less costs of the spare parts, less labor that was required to do that, and so on. So this is another, I would say, the second category where the overall, let's say, headline is reduction of maintenance cost, and itself it has the breakdown of the spare parts, labor, and so on. In both of them, there are also safety benefits. They are harder to quantify. Some clients are looking at how much training went into their safety protocols and so on. But obviously, the largest factor there is the reduction of the risk of safety. Because when you look at the statistics, and there's a very famous McKinsey article about it, when you look at the frequency of safety events in unplanned downtime versus planned one, it's really factors apart. It's 3 to 5 times more. And the reason is that you do something that's unplanned in the middle of the night. You don't necessarily have the equipment. You're in a rush. And obviously that all translates to a higher risk. While if it's planned, even if that equipment is deteriorating, if you know about it a month in advance, you're able to plan it. You do it in daytime, in regular shift. There is no rush and everything is okay. And it really translates to less injuries and sometimes even more severe consequences.
What is sensor fusion and why is it a game changer? And I suppose following on from that, how does DataMind AI handle real-time monitoring in extreme environments?
So it's a very good question, and I always use the analogy of doctors. So I'm the only one in my family that's not a doctor. I'm surrounded by doctors all day, and I see many analogies between how they work and what we do. We are essentially doctors for machines. And we went to the direction of sensor fusion because when you look at how doctor operates, how a doctor works, it makes a lot of sense, right? When you don't feel well, you go to a doctor, and the doctor has many data sources. They have CTs, MRIs, blood work, ultrasound. So there are many different data sources that the doctor basically combines together to make a diagnosis. There isn't such a thing as a doctor only of ultrasound or a doctor only of CT. And it makes sense because there is no single sensor type that can diagnose everything. And when we look at how industrial, let's say mines or heavy industry, other sites, heavy industrial sites work, many times they put a sensor, that sensor has some threshold on that specific value, and that's basically what they're doing. And when you try and think of how doctors work, it's completely different. And we actually went with the methodology of doctors, and it proved itself because it gave us dramatically higher or better results. It means that we combine together the oil analysis from the laboratory, we combine it together with vibration, we combine it with cameras. We actually have very unique oil sensors that give us minute-by-minute oil condition that most sites don't have. We combine it with pressures and flows of pumps wherever they exist. And basically, all of that combination together allows us to, number one, cover more failures. Just like a doctor uses all of these to cover more illnesses, we do the same. But even if there is some failure, it's not a matter of telling the temperature here is above 70 and then what do I need to do with it, but rather what is the failure mode, what is the exact root cause, and what are the specific actions that if you do them, you will not see it again in the future. So basically the same methodology of doctors prescribing you what needs to be done to basically get better. Same thing, but applied for machines, both fixed assets and mobile fleets.
Can you share some specific examples of where DataMind AI detected failures and maybe others have missed? And what's the fastest ROI you've seen?
Sure. So I can give, I guess, two examples. One examples are just failure modes that cannot be identified with the regular sensors that are on site. For example, one of the differentiations that we have is using cameras for failure diagnosis and for other operational issues diagnosis. I will give an example for that. We're looking at the discharge of crushers. We're measuring the ore size in real time. And if you have liner wear in the crushers, you will see a trend in the ore size. In order to measure that ore size, obviously we need to look at the belt, to measure every rock, to build statistics and to see that trend where the rocks are becoming larger and larger. And normally there is plenty of time for you to react, either to replace the liners or to calibrate the gap before it's too late. Any other sensors that you would put, whether you put vibration sensors or whatever, or motor currents, you would not be able to see that phenomena there. So there's a group of phenomena. Conveyors are one good example. So we have oversized doors, as I said. We have drift issues of the belt itself. We have rips of the belt, monitoring of the clips that cause rips when they deteriorate, which is very important in many underground mines, as I said, but also in plants. Because when there is a rip, obviously everything stops. That line stops, and it's normally a headache for the site. In these cases, by the way, our systems can actually send a command to the SCADA to stop the belt immediately, even if it's something that's unpredictable. For example, some contamination in the material or some very large, sharp rock that just fell on the belt and ripped it. There is a very large difference between stopping it on the spot after less than a second or letting it run for 15, 20 minutes where you need to replace the entire belt and not, some very small section. So this is one group as an example of failures that cannot be identified with the regular sensors on site. Another group of failures are failures that require the combination of many sensors in order to be able to see it. I'll try to explain it. mining is pretty unique in the sense that there are huge variations in the operation itself. You have more ore, less ore, larger rocks, smaller rocks, and all of that adds a lot of noise to the sensors. You can see it in SCADA, you can see the data going all over the place. And that noise is many times dramatically higher than the tiny signal of the failure. For example, one of the critical pieces of machines in copper sites, gold sites, but also other precious metals are mills. And you have, for example, a motor of a mill. It's the size of this room. 2.5 megawatts is not uncommon to see. And inside that huge motor, the bearing is roughly this size. So even if this bearing is failing, many times it's just unseen in that huge noise caused by all the variations of the operations. And what we do is we actually combine together both the motor current, the tachometer, and the vibration to completely remove the noise. We do it in very sophisticated algorithms. For example, we always track the same load and the same speed. So all of these operational variations are removed. We then apply envelope demodulation on top, which is another sophisticated algorithm. But the bottom line is that all of that removes the noise, and then you're able to see the signal of the failures. We had a site that just recently they had deterioration in their one of the bearings of the mill motor, and we saw very severe deterioration happening over a few weeks, and we alerted the site. The site sent their own vibration analysts, to the machine. They recorded regular vibration, and they didn't see anything. In our system, they've seen this severe deterioration. The diagnosis was actually that during the shutdown that they had, they forgot to rotate the mill, and it actually caused damage to the bearings. So it was a human error, basically, that induced that deterioration. And they took our word for it. They replaced the motor, they took it apart, and they've seen that severe damage to the bearing that would otherwise would have caused, at least a few days of downtime, because you need a crane, you bring it over a weekend. It's a nightmare, and it was completely avoided because they just reshuffled the tasks the week after. They did it plenty of time in advance, weeks in advance, just replaced it with a new one, didn't have any interruptions and anything. So these are the two main groups. Number one is identifying failures that cannot be identified with the current sensors on site because we simply use other sensors that are meant for health. And second one is identifying failures that can only be identified by this sensor fusion. And we work today both in fixed assets, whether it's mills, crushers, conveyors, critical slurry pumps, compressors, and others, where the exact phenomena can be seen, but also in haul trucks and other LHDs and other mobile fleet equipment, where you use both the sensors on the vehicle itself, but also the fluids like the coolant analysis, oil analysis, and so on, tire information, suspension information, and so on. And combining all of that really gives us much larger failure coverage in comparison to what the OEMs can deliver.
And what would you say the fastest ROI you've actually seen when using your system?
So the ROI, the return on investment that we've seen is, I'll give you an example. We had a major deployment in a coal site. There was a CHPP, a coal prep plant, and we installed half of the machines at that point of the ROI calculation, and they were able to return the entire investment in under 3 months. And that's not uncommon. These are roughly the numbers. Between, let's say, 2 to 4 months are nominally the ROIs. The reason is that in the first place, we choose the critical equipment, the one that's agreed even before the installation that the impact of the downtime there is the most severe. And basically, we prepared together with the site basically a table that shows these were the failures that were prevented. The site has these categories of maintenance cost, downtime impact, spare parts, and so on. And they basically put a number, you sum it up, and you see that your entire investment was returned really in 2 to 4 months.
How does real-time AI change day-to-day maintenance work? And also, how do you help teams trust and transition to AI-driven systems?
So it's a very good question. I'll start with the second one because it's really it took us some time to get to this point. Traditional AI systems are black box. Basically, the AI traditionally takes in information, spits out an answer, and that's it. You need to trust it. You need to believe it. You don't have anything else to do. We understood it in mining, which is more of a conservative market, and it's mission critical, right? That's one of the reasons it's more conservative. It doesn't make sense. You cannot trust the model. You cannot replace an engine that's $400,000 or a critical gearbox that's $100,000 by trusting a black box. And our AI is actually delivering what we call an evidence. It actually shows from all the terabytes of data that it gathered from all the sensors, it shows this is the reason why I made the diagnosis. I've seen this trend here based on that operational filtering and so on and so on. If I applied an algorithm, I'm showing, or the AI is showing them the result of the algorithm. If there's spectral analysis where actually the AI marks what frequencies made it believe that this is the right diagnosis, and then an expert on site, whether it's a reliability engineer, a conman, a condition monitoring engineer, is able to look at it and say, okay, I understand. I understand why it's been done and why that is the diagnosis there, and then I can obviously approve to my maintenance team to perform the maintenance itself, whether it's replacement of some component or lubrication or other. So the evidence is a critical part, and unfortunately, when we look at other AI systems today in the market, it's not a common, unfortunately, feature there, where I think it's really critical, at least for the mining industry. Your other question was regarding the real-time monitoring, and I want to address this question. So let's see what happens today on sites, right? And so we have so we can do a comparison. Today we see two groups of solutions basically for health monitoring. One is basically you every month, roughly, depending on the site, you come to the machine, you record yourself, let's say vibration in most cases, you might take an oil sample, and you only monitor that machine basically once a month. Two things happen. First of all, by definition, any mechanical deterioration that will happen in between, you will miss it. And many times it would be critical failure modes, very expensive ones. By monitoring it continuously, you by definition make sure that no matter whether it's deteriorating over 3 weeks time or 2 weeks time, you will be able to capture it. That's number one. Number two, we need to remember that even if you captured it, if you capture it too late, the price of the maintenance actually goes up with every day that passes by. I'll give you an example. Let's say you have a friction in the gearbox. If you know about it early on, because you're continuously monitoring that gearbox, in many cases you would, lubricate it. Maybe your automatic lubrication device is not working, so you will replace it. But it will be many times very easy fix, cheap one, and a quick one. But if you know about it only after a month, in many cases you will need to replace the entire gearbox, which is dramatically more expensive. It will take at least a few hours of shutdown. You will need to buy a new one. So capturing things earlier becomes also with a very tangible financial impact. It's not just, a convenience. When we look at the other types of systems, which are basically SCADA alarms, right? Any site has SCADA, they have alarms. The problems with these alarms is that for starters, they're only limited to the sensors on site. So they're not capturing all the failures that can happen to, let's say, the critical equipment at least. And the second is that the site is bombarded with thousands of these false alarms, right? Any site has of these. And the reason is that it's just a simple threshold, a temperature is above 70 degrees as an example. Every time it reaches this threshold, there is an alarm. Many times there is nothing wrong. Many times it's just some temporary change in the operations. And it's just impractical to investigate each and every one of these alarms. There is no enough team size for that. and many of these alarms are just disregarded, which itself obviously leads to failures. Our system doesn't just put a simple threshold, but applies, as I said, much more sophisticated algorithms that actually perform diagnosis, like a doctor, for all of these data sources together, the oil, the cameras, the vibration, pressures and flows, everything that I mentioned, to give a real diagnosis that they can really act upon. Because not every day, obviously, an equipment fails, right? So they're really focused on the specific pieces that now need their attention, unlike thousands of alarms that are bombarding them.
So if you look at the bigger picture and the strategic outlook, what does the next 5 to 10 years look like for the company?
So it's a very good question. I think we have several verticals of expansion. The first vertical is an operational one. So we started with fixed assets. We saw amazing case studies and amazing success there. We started with a single geography and really expanded. But then we understood that the same technology can be applied to mobile fleets. So a year ago, we started the adaptation to the mobile fleets, and we now are able to monitor also haul trucks, whether it's Komatsu or CAT. We're completely vendor agnostic, and even LHDs underground. We're able today to connect to vehicles that are not connected to any servers at all by deploying a tiny data logger that extracts the information from the sensors on board. The rest of the systems, like the oil analysis, is very easily integrated to, and we basically deliver diagnosis to them. So an expansion vertical there would be to also expand to excavators, to dozers, and so on, and really to the rest of the equipment. In addition, the technology itself doesn't really care whether it's a mine site or another heavy industry site. We are now starting to work also with oil refineries. We signed an agreement with Siemens Energy on power plants. So it's really not only looking at mines, but also other heavy industry sites that where downtime matters, where downtime really causes severe losses. Really looking from more of the financial side. We're today a public company, but we would like to double list in NASDAQ. I would say that this is our next challenge, and this is where we're working very hard to get to as soon as possible.
And what's next for Razor Labs and DataMind AI over the next 12 to 18 months?
I think that really in the really upcoming future, in the near future, it's really adding the additional or the rest of the mobile fleets. I think it's not even 18 months, I would say under 12 months, to make sure that every mobile fleet vehicle, whether it's mechanical drive, hydraulic drive, electrical drive, can be covered out of the box. By the way, we've put a lot of R&D to make sure that when we deploy the system, it does not need to be trained or to be taught or anything. It just works out of the box. It required some very sophisticated training techniques because, as you know, AI learns from examples, but we don't have the luxury of learning from scratch on new sites because it will take forever. We want the system to come pre-equipped with all the knowledge, just be deployed, and that's it. So we have accomplished this one for fixed assets, haul trucks, as I said. And I think that really in the next even few months, going to excavators and dozers, as I said, I think it's the next frontier. And obviously continuing our geographical expansion. I mean, both in Australia, in the rest of Africa, Latin America, North America, Europe, and so on. So expanding also the installation base on each and every one of them.
And lastly, if there was something that you could leave our listeners, whether they're obviously engineers on site, whether they're maintenance planners or executives thinking about obviously digital transformation, with one insight, what would be the role of AI in the future of mining maintenance? And also, how should they be thinking about unplanned downtime, systems safety, and the shift towards real-time trusted AI-driven decisions?
So I think that if I needed to leave one message to the listeners is that traditional or older AI systems, my thoughts were not suitable for mining. They were hard to deploy. They took long calibration times already after installation, not really suitable for mining. But the modern AI systems, systems that already come with the knowledge, systems that are just deployed and they work, like you buy an iPhone, right? You don't need to do anything else. It just works out of the box. These systems are not only dramatically easier to deploy, but for starters, they don't require any prerequisites from site. You don't need any special sensor. It already comes with all the hardware that's necessary. But they can really transform operations. They transform them into more, into safer operations. That's number one. You don't need to be near an equipment that's about to blow up and take vibration readings, which is obviously unsafe. They are like co-pilots that tell you that here are the places that you need to focus on to really make sure that the production is stable and it's on track without taking any of the control from you. So you have all the evidence to know why specific recommendation was made. It's not a decision that's made for the site, but it's always recommendation. And just like we started working with ChatGPT, 2 years ago, roughly, and we cannot, I think, we cannot envision the lives without ChatGPT today because it's such an amazing assistant. I think it's really the same concept for mining. It's having that co-pilot that monitors everything all the time, 24/7 continuously, which is obviously impractical for to be done by humans, and really taking the site team, focusing them on what's critical, and making sure that operations are streamlined and safer.
Michael, really appreciate your time coming on the podcast, explaining, tell us a little bit more about obviously Razor Labs, how you've grown as a business over the last decade, and obviously telling us about DataMind AI and how it can be used in the mining industry, and obviously your plans moving forward to obviously expand the product range and into different machines as well. So if our audience wants to reach out to you, if they've got any questions, if they want to follow updates, maybe new releases, how can they go about doing that, and what social media platform channels are you on?
Just go to our website. It's Razor, R-A-Z-O-R dash labs, as in laboratories.com. That's it. There's a form there that you can fill with any question, and we'll be happy to answer everything.
Yeah, we'll include those in the show notes, accompanies for easy access to our listeners. So all the best for the future. And I'm sure our audience will reach out to you if they've got any questions or obviously want to know more about your products. I'm sure they'll be in touch with you soon.
Thank you very much, Rob. It was a pleasure.
No worries. Thank you. Thank you for listening. As always, appreciate your continued support. Please keep sharing these episodes far and wide. This is obviously relevant to a lot of our listeners who work in operations, and maybe something that you should look at and visit their website, because we all obviously want to improve. We want to increase efficiencies and obviously less downtime. And Razor Labs is something, their products can obviously help you with that. So as always, appreciate your continued support. Please keep sharing these episodes far and wide all across the globe. And until next time, happy mining.
Thank you for listening. Remember to reach out to Rob via the show notes, and be sure to subscribe and leave a review. Until next time, happy mining, helping each other to improve the mining industry.